Well, you've certainly got a lot of practice on finding reference angles. But the question is, why do you learn them? How are we going to use reference angles? And how are we going to go full circle with our trigonometry? Well, let's talk about that. These first few slides remind you of what you've already seen other teachers talking about on the previous videos. For instance, reference angles are always acute, positive angles that fall between the terminal side of an angle and the x-axis. I'll remind you, if I give you the angle in degrees, you're going to answer in degrees. If I give you decimal radians, you're going to answer in decimal radians. And if I give you exact radians, which would be fractions with pi, then that's the way you're going to answer as well. You may want to go back to the last 12 problems that I just skipped over, and you may want to rework those problems on your own as practice problems, and then you can check what I gave and see if you're right. All this information will be posted as a PDF document on Blackboard as usual. Now, if you look at this slide, I am just summarizing the major angles as I color-coded them the very first day of trig. So your four 30-degree multiples are 30, 150, 210, and 330 degrees shown in blue. The reference angle for each of those is 30 degrees because those angles are all 30 degrees from the x-axis. Then you've got your multiples of 45, which are 45, 135, 225, and 315. They're all 45 degrees from the x-axis, so their reference angle is 45 degrees. And then the green angles are multiples of 60. That's 60, 120, 240, and 300 degrees. They're all 60 degrees from the x-axis, so their reference angles are 60 degrees. So each quadrant contains a major angle with a reference angle of 30, a reference angle of 45, and a reference angle of 60 degrees. That's going to help us go full circle. Now, if you look at this information in radians, then it becomes even more significant. So the blue angles are multiples of pi over 6. 1, 5, 7, and 11 pi over 6 all have a reference angle of pi over 6. In fact, guys, any multiple of pi over 6 automatically has a reference angle of pi over 6. So you don't have to work very hard to calculate a reference angle. Ditto for the red angles. 1, 3, 5, and 7 pi over 4 are your multiples of pi over 4 in the first go-round of the unit circle. They all have reference angles of pi over 4. Let me say again, any multiple of pi over 4 has a reference angle of pi over 4. Isn't that nice? You can just truncate to get reference angle. You don't have to work hard at it. And any multiple of pi over 3, which in the first unit circle trip around the unit circle, it's 1, 3, 1, 2, 4, and 5 pi over 3. They're multiples of pi over 3. Therefore, their reference angles are pi over 3. And that's why I color-coded the spokes on the wheel the way I did the very first day of trig class. Now let's back up because I don't want you to have a misperception. Do you see on number 9 that this is a minor angle and it's a multiple of pi over 12? I can't assume, however, that its reference angle is just pi over 12. If you go from 12 pi over 12 to 17 pi over 12, that's a reference angle of 5 pi over 12. So multiples of major angles will automatically give you pi over 6, pi over 4, or pi over 3 as reference angles, but multiples of minor angles aren't automatic. Now number 10, it's a multiple of pi over 15, and the reference angle turned out to be pi over 15, but it didn't have to be that way. Consider, what if number 10 had given you 28 pi over 15? Its reference angle would be 2 pi over 15, not 1 pi over 15. So it's a great trick for multiples of major angles, but it does not work for minor angles. Okay, so again, the question is, how are we going to use reference angles and why are we doing all this stuff? Well, back before calculators were prevalent, before everybody had calculators, what we did use were slide rules. And even when the earliest calculators came out, and most all students had like solar generated pocket calculators, which is how it was when I was in high school, A lot of those calculators at that time would not calculate anything except trig values for 0 degrees up through 90 degrees. So we oftentimes had to refer to trig tables like the one I've shown you, or we had to use our calculators. Well, let me explain how we did both. Let's suppose I ask you to find the sine of, we'll even say 95 degrees. Okay, well, 95 degrees is in the second quadrant, in the sine quadrant, and so I know it's going to turn out positive. Well, my calculator wouldn't have done sine 95. It wouldn't do anything over sine 90. So what I had to do was think, okay, well, 95 degrees is 85 degrees, which is here, from the x-axis. So sine 95 would have equaled sine 85. And then I would have simply looked in my calculator and said the sine value, not my calculator, but 0.9962 if I was using a trig table. But my calculator would have also done the same thing. So I had to know, because my calculator couldn't handle sine 95, I had to know that the answer was going to be positive, and I had to know to actually punch sine 85 in my calculator. Well, you might be going, well, that's kind of crazy because our calculators today do all that, and you're right. But we still have a reason to know reference angles. But just for a minute, let's practice. What if I said, let's do the cosine of 100 degrees? Well, I could ask you on the test to just tell me what that's equal in terms of its reference angle. Well, 100 degrees is in the sine quadrant, therefore cosine will be negative, and you have to add that positive or negative sign. 100 degrees is 80 degrees from the x-axis. So you need to know cosine 100 will match negative cosine 80. Well, you might say, well, that's crazy. Is it? Let's check. You can see that what I've done is in degree mode on my calculator, I punched in cosine 100 and negative cosine 80. And do you see that the trig values are the same? So I'm not pulling your leg. This is the real McCoy. Let's practice a few more. What if I said, let's find the tangent of 160 degrees? Well, again, you need to say tangent, or 160 is in the sine quadrant, where tangent will be negative. So what I would need to plug in my calculator would be tangent of, think, what's the reference angle for 160? Are you saying 20 degrees? If so, you're right. And I'm intentionally using really simple angle measures because we want to do this quickly and get it out of the way. Well, I could also say, well, what about the sine of, we'll say 200 degrees. I'll keep it simple. So tell yourself 200 degrees is in the tangent quadrant, so sine must be negative. Well, what's the reference angle for 200? Well, 200 is still 20 degrees beyond the 180 degree x-axis, so sine 200 equals negative sine 20. Okay, well, I'm going to skip a little bit. What about cosine of, we'll say, how about 195? Well, 195 is in the tangent quadrant where cosine is negative, so write the negative cosine down. What's the reference angle for 195? It's 15 degrees. Well, what about the tangent of like 240 degrees? Well, 240 is in the tangent quadrant, so it's going to turn out positive. I'll write the positive just for emphasis so you remember I thought about it. And 240 degrees is 60 degrees beyond the 180 degree x-axis. All right, well, we could do the same thing if I said, well, what about the cosine of, let's say, 310 degrees? Now you're going to say, well, cosine, or 310 is in the cosine quadrant where cosine will be positive, and the reference angle for 310 degrees is 50 degrees. I'm going to do just a couple more and then move on, and then you can ask me more about this tomorrow if I haven't done enough examples for it to make sense. What if I ask you about cosecant of 320 degrees? All right, well, guys, 320 degrees is in the cosine quadrant where sine is negative and therefore cosecant is negative. So now say the reference angle for 320 degrees is, what do you think? Did you say 40? How about we do one more? How about the secant of 260 degrees? Can you do that one? What quadrant is 260 degrees in? Did you say the tangent quadrant? Now, would that make secant positive or negative? I hope you said negative. Last piece of the puzzle. What's the reference angle for 260 degrees? If you said 80 degrees, you're correct. So, how are you going to use this beyond the need to just answer questions if I say answer in terms of a reference angle? Now we're going full circle without calculators. We're focused on the major angles. So if the major angle falls on an axis, then you're going to revert to what we did yesterday and draw the circle with the ones and zeros. You might want to go ahead and do that right now if you don't have it out in front of you. You're fixing to use it. If the major angle falls within a quadrant, then it's a three-step process. First, figure out in what quadrant the angle falls and use all students take calculus to decide if the answer will be positive or negative. Then, come up with the reference angle. That's what we were just doing on the previous chart. Then, since the reference angle will be 30, 45, or 60, use the 30, 40, 60, 90 triangle or the 45, 45, 90 triangle to get the answer. Take a minute and make sure you've got your circle with the ones and zeros drawn and your two special right triangles drawn, and away we go. If I ask you to evaluate the sine of 120 degrees, I need you to know that 120 is in the sine quadrant, therefore it's positive. Then I need you to know that 120 degrees reference angle is 60 degrees. Then I need you to look at your 60-degree yellow triangle and say sine is opposite over hypotenuse, square root 3 over 2. That was steps 1, 2, and 3. So cosine 225. Step 1. 225 is in the tangent quadrant. Cosine will be negative. Step 2. The reference angle for 225 is 45. Step 3. The green triangle shows me that cosine 45 is adjacent over hypotenuse. 1 over root 2 is root 2 over 2. And don't forget, it's negative. Tangent 330, excuse me. Step 1. 330 is in the cosine quadrant. Tangent will be negative. The reference angle for 330 is 30. Step 3 is to use the yellow triangle. Tangent 30 is 1 over square root 3 equals square root 3 over 3. Cosecant 315. Let's go through this. First, 315 is in the tangent quadrant. Cosecant and sine are both negative. The reference angle is 45 degrees. Looking at the green triangle, sine 45 is 1 over root 2. Cosecant 45 is root 2 over 1. I'm starting to trim out the steps. I'm still thinking about the middle step. I'm just not writing it. And you can do either one. You may write everything today and by tomorrow be ready to wean out the step. And that's on your timetable when you wean the middle step out of your work. Secant 300. 300's in the cosine quadrant. Secant will be positive. The reference angle is 60. When I look at the yellow triangle, cosine 60 is 1 over 2. Therefore, secant 60 is 2 over 1. Cotangent 135 is in the sine quadrant. Therefore, cotangent and tangent are negative. The reference angle is 45. Tangent 45 is 1 over 1. So is cotangent 45. Whoa, what am I doing changing colors? Being school-spirited? No. 270 degrees isn't in a quadrant. It's on an axis. So rebound to what you learned yesterday with the 0 and 1 circle. 270 is down here at the point 0, negative 1. Sines y. That's negative 1. Tangent 180 is on the negative x-axis at negative 1, 0. Tangent is sine over cosine. y over x is 0 over negative 1 is 0. I'm going to rebound from black to red so that you get used to being elastic in the way you're thinking about things. So 150 is in the sine quadrant. Cosine and secant are negative. The reference angle is 30 degrees. Cosine 30 is the square root of 3 over 2. Therefore, secant is 2 over square root 3. That means 2 square root 3 over 3. 240 is in the tan quadrant. Tan and cotan are positive. The reference angle is 60. Tangent is the square root of 3 over 1. Therefore, cotangent is 1 over the square root of 3, or the square root of 3 over 3. Uh-oh, rebound. 0 degrees is on the positive x-axis at your 1, 0 point. Sine's y, so cosine is x. Cosecant 210. 210's in the tangent quadrant. Sine and cosecant are negative. The reference angle is 30 degrees. Sine 30 is 1/2. Cosecant is 2 over 1. Secant 90. 90 is up here at 0, 1. Secant's 1 over cosine. 1 over x. Undefined. Negative 90 is down here at 0, negative 1. Cotangent is cosine over sine. Cosine over sine. X over y. 0 over negative 1 is 0. 630. Guys, that is 7 times 90. So 1, 2, 3, 4, 5, 6, 7. 7 times 90, or 7 pi over 2, is down here at 0, negative 1. Cosecant's 1 over sine. 1 over y is negative 1. Now, negative 210, if you look at negative 210, we're just going backward, negative 90, negative 180, negative 210. We're in the sine quadrant, so sine will be positive. Just like sine, the 210's reference angle is 30, so is negative 210's reference angle. So go to sine 30 and say 1/2, and ha-ha, you are done. That's a huge deal for you all to practice.